All right, hello, it's Mr. Bird again. Today we're going to start solving some logarithmic equations. And on the board here I have the two basic types. Now, we have one where there's a logarithm here on one side equal to a number, or just equal to something else. And what we're going to do is think of this ln as a natural log of x. It's really a log of base e of x equals 4. And all we do is the loop-de-loop. The base is e. We take that to the fourth power, and that equals x. So to find your answer, you just have to do e to the fourth power. So second ln brings up e. You put it to the fourth power. Now normally we round these to 3 decimal places. So my answer is about 54.598. Okay. So if I can get a logarithm by itself on one side, I just rewrite it as an exponential equation doing the loop. I get my answer. Now sometimes this might be more than just x and you'll have to do some other work to solve it. The next type is if I have more than one logarithm, I try to get a logarithm on each side. So I'm going to add the natural log of 8 to both sides. And I get the natural log of x equals natural log of 8. That means x has to equal 8. So those are our two basic type of logarithmic equations. Now I'm going to do a couple other examples to show you how this works. So let's see, let's take a log where there's no base listed there. That means its base is 10. And we're going to take that of, let's say, 3x plus 5. And we're going to set that equal to 8. Now let's make it a little smaller. Let's do it with just 2. So again, I have a single logarithm on one side equal to a number. Whenever I have that, I want to try to use the loop. Now remember, this logarithm, when there's none written there, has a base of 10. It's one of the two logarithms on your calculator. So again, I do the loop. 10 to the second power equals 3x plus 5. And now I can solve this for x. So I get 100 equals 3x plus 5. Subtract 5, I get 95 equals 3x. Make that 3 look a little better there. I divide by 3. So let's see, 95 goes into 3, 32 or 31 and 2/3, or 31.6 repeating. So if I can ever get a logarithm by itself on one side, I can then solve it by doing the loop. So let's take this a little bit farther. What if I have, let's see, a base 3 logarithm of x. Let's see, plus a base 3 logarithm of x minus 8. And that is equal to 2. So I have two logarithms, but I'm adding here. And I don't just have two logarithms like I had in a previous problem, the second one I did. So I would like to get this to be just a single logarithm. Well, since I'm adding two logarithms with the same base, I can make it a single logarithm. Again, it'll be a base 3 logarithm of the product of what I was taking the logarithms of, x and x minus 8. Again, we had 3 properties before this all started, and we had to come home. You did a worksheet on the first day of this continuative education where you had to condense logarithms. This is why you had to do that. And then this equals 2. So what I need to do is the loop-de-loop. So 3 to the second power equals x times x minus 8. So what I've got now is an equation to solve. It's not a linear equation, it's a quadratic equation. But we should all know how to solve these. So on the left side I get 9. On the right side I distribute, I get x squared minus 8x. I subtract 9 from both sides. So I have x squared minus 8x minus 9. That factors be x minus 9 times x plus 1. And I would have x equals 9 and negative 1. Now, here's where we got to think of what we know about logarithms. So here I have a base 3 logarithm of x. If you would take your calculator and plug that in and replace x with a negative 1, you will have a problem, right? So if I try to take a base 3 logarithm of negative 1, I have to use my change of base formula in this calculator because I can't do it otherwise. Remember the base one on the bottom. So it'll be the natural log of negative 1 divided by the natural log of 3. So if I take the natural log of negative 1 divided by the natural log of 3, it gives me an error, non-real answer, because you can never take a logarithm of something that's negative, right? Not real. So as long as these values here where I have x and x minus 8 do not become negative, we can actually plug in a number. If I plug in negative 1 here or here, it becomes negative. So I can only have the value of 9 there. Okay? So basically I'm saying a base 3 log of 9, which would be 2. A base 3 log of 1 would be 0. 2 plus 0 is 2 if I check it. So I'm going to be giving you a few problems to work on. And let's see, they are on page 213 and 214. We're going to do, let's see, 40, or let's change that 27 to 35. And we're also going to try 73 through 89. And those are the odds. So, give these a try. Probably the next day, so tomorrow, we'll even do some more practice with solving logarithmic equations. Remember, if you have questions, don't be afraid to ask. I'm again available, as it says on Schoology, via Zoom. Not too many people have been contacting me that way. Otherwise, you could also do some emails, and we can, try to answer questions that way. So there you go. Have fun. Good luck.